Hello, 8th grade math. This is a video lesson to help you complete the second assignment of week 5 of AMI over roots. This is actually module 7, lesson 2. So we did Pythagorean theorem in lesson 1, where we were looking at how to find the missing side length of a right triangle. Well, starting in this lesson, we're going to go into how to find the exact answers to questions like that. And we're going to be looking at using what's called a root. So the most common and easiest kind that we'll use the most is called a square root. And that's what we're going to be looking at in this lesson, is how to use those and what they mean. So the first thing I want us to look at is what the root symbol looks like. So here's one typed in on the computer, but typically you're going to see it look a little bit differently. It's more often going to be a little longer because you're going to have some kind of number written underneath it. So it looks like a long division bar, but it's called a root symbol. Now, if there's no number in this spot right here, put a B for this placeholder. If I have no number in the B spot, then this is just a square root, like what we're going to work with today. If you might in the future see a different number there, like a 3 or a 4, those would be called cube roots, fourth roots, and there's different names for them. But when there's no number, it's called a square root. So that's what we're going to be looking at. So let's go ahead and take a look at my example for how I'd like to just demonstrate to you how these work. So you've learned previously that using exponents is the process of repeated multiplication. It's multiplying the same number times itself multiple times. So if I were to ask you x squared equals 25, that would be me asking you what number multiplied times itself twice is equal to 25. So we should know that one fairly easily. You should know the multiplication fact of 5 squared, or 5 times 5, is equal to 25. Now, if I wanted to go backwards from that and work the opposite direction, I would have to use a root. I would use a square root. If I were to ask what the square root of 25 is equal to, that is asking what number multiplied times itself would equal 25. And we know the answer is 5 based off of how we know our perfect squares. Now, excuse me. So taking a square root is the inverse operation of squaring a number using an exponent of 2. So we are going to use this process to answer some questions from your assignment for this lesson. And then next week, we'll look into more applications of roots. Okay, I'm going to go ahead and pause the video and switch us over to your assignment. All right, guys, sorry about the pause there. Now, let's take a look. Question number 1, we have the square root of 169. What is that equal to? So 169 is a perfect square. So in order to find that the easiest and most simple way, you'll want to, in your calculator, type in the square root symbol. Now, even if you're just using like a phone calculator, you can access that on most. So it's going to be the symbol that looks like what I showed you on the previous page. We'll have the square root sign, and then you would, after you type that button, you want to put in your number, 169, and then you'd click enter or equals, however your calculator works. And then from there, you should get that the answer is going to be 13. Now, that's as far as we are going to take a question like that today. So from there, since I have that the answer is 13, I'm going to go ahead and put that over here. So I'm going to leave you guys to do questions 2 and 3 on your own, because those are also perfect squares. But now let's take a look at how you're going to do number 4. Number 4 asks for the square root of 147. So if in your calculator you try to take the square root of this number, you are not going to get a whole number. That is how I know this is not a perfect square. When I take the square root of this number, it never ends. It's what we call an irrational number. I have 12.1243556529, and it just keeps going. That would be a never-ending combination of numbers. So, how we're going to answer this question is it's going to be similar to how we answered what the side lengths were on the triangles in lesson 1. I'm going to pick out the two perfect squares that this number is closest to in order to know which number it's actually all the way closest to. So based off what we had, I already told you that this is equal to about 12.1. So we know it's going to be closest to 12. But I want to walk you through that process just to make sure you understand. So the number 147 is in between 144 or 12 squared. And on the high end, it's less than 169, which is 13 squared. It is in between these two numbers. So I'm going to say which of these perfect squares it is closest to, and clearly it's closest to 144. It's only 3 away from that, whereas it's 22 away from 169. So we can say that the square root of 147 is closest to 12. Apologize, my dog's being really rowdy in the background today, guys. To 12. And I can confirm that by typing it into the calculator, which gave us that it was about 12.1. So keep that in mind. So that's a plenty good answer for me for number 4, something like this. And then you'll want to do the same on number 5 because it's also not a perfect square. And then you'll want to relate that into question number 6 in your own words. Now let's take a look at question number 7. We have placed the following list of numbers in their approximate locations on a number line. So, newsflash, none of these are perfect squares. So they're all going to be approximations. So we need to figure out what all of these approximately are. I'm going to help you with the first two, 32 and 12, and then you guys will need to do the rest on your own. So the square root of 32. Well, if I'm thinking through my perfect squares, my squares on the low end, I have 1, 4, 9, 16, 25, and 49. Well, 32 is between 25 and guys, I'm sorry, my dog keeps barking in the background. There's been animals coming up to my window all day. All right, so as I was saying, 32 is between 25 and 36. So I know that the square root of 32 has to be somewhere between 5 and 6 because the square root of 25 is 5 and the square root of 36 is 6 because that's what those numbers multiplied times themselves are equal to. So I am going to put the square root of 32 either close to 6 or close to 5, but that's going to depend on which one I think it's closest to. So 32 is 4 away from 36, but it's 7 away from 25. So I would say that the square root of 32 would be closer to 6. Now I'm going to confirm that in my calculator by trying to take the square root of 32, and I see that that's approximately 5.6. So I know for sure that this one will actually be closer to 6. So I'm going to go in here and write it. The square root of 32. Make sure you have it on the right-hand side in between 5 and 6. And then we'll have the square root of 12. So we're going to do the same process here. 12, I'll write it out this time to make sure you guys can see it well. 12 is in between these two square roots. 12 is greater than 9, but less than 16. So the square root of 9, or what multiplies times itself to equal 9, is 3. 3 times 3 is 9. For 16, what I multiply times itself to get 16 is 4. 4 times 4. So the square root of 16 is 4. So we're in between 3 and 4, here and here. It's 3 away from 9, but 4 away from 16. So this one's closer to 9. So I'm going to have the square root of 12 in between 3 and 4. Sorry for, I'm going to make that a little cleaner so you can see it a little bit better. And so you're going to do the same process for all of these numbers to plug them in. Now, if you have any trouble with this or this is confusing to you, feel free to email me or ask questions on the video and I'll get those answered for you. If you need me to put that where you can see it a little bit better, I can type something up for you. So now let's take a look at the last question. Number 8, between which two integers will the square root of 45 be located? So it's just asking you to do a very specific number and go through the same process. You don't have the number line here necessarily to use it for, or you could use the number line to help you. It's up to you. But it's going to be that same process of finding which perfect square is below 45 and which one is above 45. And then tell me which number it's closest to. All right, so that's pretty much the process for today. It's just a little bit of an introduction to square roots, practicing approximating where the number would be, and then practicing doing square roots of perfect squares. So if you have any questions, once again, feel free to let me know, but this is where I'm going to leave you off for today. All right, thank you.